We're looking at problem number 4. Let's jot down the pertinent information first. The averages for a test have a mean of 80, so let's write that down. The mean is 80. This tells us the standard deviation is 5. And they're also telling us that we're talking about a sample of 300 students. So that would mean that n is equal to 300. Let's see if we can figure out what are our cutoff points. The first cutoff point would be 78 because we're interested in finding the number of students that scored between 78 and 84. So I have two critical points, 78 and 84. Let's draw our normal curve and see if we can place this information on there and shade the appropriate region to do the problem. All right, let's get our mean on there. The mean would be right there in the center. And we know that's our 80. We also know that we want the lower endpoint to be 78. That would be to the left of the mean. So I'll put that right there, 78. And we want the upper endpoint to be 84. And we'll put that on the right-hand side. Again, we're not looking for a work of art. All right, since we want between these two values, I know that I want this section of the graph as well as this section. Okay, so I know exactly what regions I'm looking for. The next job would be to take a look at the z-scores. Let's remember that z is equal to the raw score, the x, minus the mean, and then divided by the standard deviation. Don't forget when you calculate this, you either need to put parentheses around your numerator or make sure you hit equals after you do the subtraction. So let's find the z-score that corresponds to 78 first. All right, that means we put in 78 minus the mean, which is 80, then divide by the standard deviation, which was 5. That will give us a z-score of negative 0.4. Do the same thing for 84. Okay, we'll have 84 minus 80, then divided by 5, and that will give us a z-score of positive 0.8. The fact that the z-score for 78 is negative confirms the fact that that's on the left side of the mean. The fact that the z-score for 84 is a positive 0.8 confirms the fact that that would be to the right of the mean. Now we'll go to the table and we'll look up the corresponding areas for z equal to 0.4 and z equal to 0.8. Looking at the table, we find that the area corresponding to 0.4 is equal to 0.155. We find that the area corresponding to 0.8 is 0.288. Because these are on opposite sides of the mean, and each of these values gets me to the mean, so I know that from here to here would be an area of 0.155 of the graph, and from here to here would be 0.288. In order to find the total area encompassed by that, all I do is add these two together, and I would get 0.443. Now, if the problem had said, find the probability that we choose a student at random and it would land within this score range, I would be done. If it asked me to say, if it asked what percent of the scores lie between 78 and 84, I would simply change this to a percentage, which would make it 44.3%. But the question said, how many of the 300 students does that represent? So in this particular case, I have one more step, and that would be to take the 0.443 and multiply it by the 300 students, okay, which gives us 133.05, which rounds off to 133 students.